This is the video for Unit 2 study guide. Help you guys figure what to do out for this unit and then work on your corrections. Submit your corrections somehow. Either submit them to me or take a picture or screenshot and send them to me. And then I'll arrange for you guys to take the retest and try and raise your grade. So here we go for Unit 2. First thing you want to do is convert degrees to radians. All right, you are going to need your calculator for this. So to do this, you're going to multiply each thing. So let's get the pen out there. You're going to multiply by pi over 180. So you have 365. All right, divide both sides, divided by 180. And then make your fraction. So you're going to have 73 pi over 36. So if you reduce your fraction and then put pi in the top, you're going to have your radian. Okay, so next one, -8 times pi over 180. So -8 divided by 180. Your fraction is going to be -2 pi over 45. And lastly, you have 15 divided by 2 times pi over 180. All right, and then if you get your fraction, you will get pi over 24. And those are going to be your radians. If you want to go reverse, if you want to get a radian converted to degrees, you're going to do the reciprocal of what we just did up top. You're going to multiply by 180 over pi. So you have 1/5, or actually you can just do 180 divided by 5. Okay, the pi's cancel out and you will get 36 degrees. 7 over 9 times 180 over pi. You will get 140 degrees. And finally, 6 pi times 180 over pi. Again, the pi's will cancel out, and 6 times 180 is 1,080 degrees. That's what you got. All right, next, these questions, you're going to need your unit circle for this. All right, what you're going to do is you're going to find out what the values are of these particular radians, okay, and the trig function, and then you're going to multiply the fractions together. So for the sine of 5 pi over 3, if we look at 5 pi over 3, and the sine is going to be the y value, it is -√3 over 2. For tangent of 2 pi over 3, we look at 2 pi over 3, it's going to be the y divided by x, so you have √3 over 2. Divided by -1/2. Okay, so we have this complex fraction, we need to get rid of it, so we're going to multiply by the reciprocal of the denominator, so -2 over 1. So this all cancels on the bottom, the 2's cancel, and you're left with -√3. So if we do, and that's going to be, if we multiply what we have over here of -√3 over 2 times the square root of 3, square root of 3 times square root of 3 is going to be the square root of 9. The square root of 9 is just 3. The two negatives gives you a positive, so you have 3 over 2. All right, the 2 gets multiplied by 1 on the denominator of the square root of 3, so it doesn't change. Next, cosine of 3 pi over 2. The cosine of 3 pi over 2 is 0. All right, and the tangent of pi over 6, all right, pi over 6 is going to be 1/2 divided by √3 over 2. Okay, again, we can multiply this, but we don't have to because the cosine of 3 pi over 2 is 0, and anything times 0 is just going to be 0. And lastly, the tangent of 5 pi over 4 is going to be -√2 over 2 divided by -√2 over 2. And that is going to give you, since it's the same thing divided by itself, it's going to give you +1. Okay, and then the sine is 7 pi over 6. So the y value of 7 pi over 6 is negative 1/2. So 1 times negative 1/2 is equal to negative 1/2. Okay, so we're just multiplying straight across after we find the fractions or the values for those particular trig functions. All right, number 10. We're going to draw a little triangle out of this. Go negative 5 to the left, and then positive 12 up. So it makes this triangle. And our degree, our angle is going to be closest to the origin. So what we have to do is we have to find the hypotenuse of this triangle. So we have to do Pythagorean theorem. So we have negative 5 squared, so it's 25, plus 12 squared is 144. Gives us the 169, so the square root of 169 is 13. So we find the sine, cosine, and tangent of this triangle using those values. So the sine is the opposite over the hypotenuse. So we have 12 over 13. Cosine is adjacent over hypotenuse, so it's negative 5 over 13. And the tangent is opposite over adjacent, so we have 12 over negative 5. Okay, so that's it for 10. For number 11, the same idea. We go 8 to the right, and then we go down 1. Make our triangle. So this is negative 1, this is positive 8. We're going to use the Pythagorean theorem to find the hypotenuse. So we do 8 squared is 64, negative 1 squared is 1. So we're going to have the square root of 65. Okay. Now we're going to find if we know that theta is closest to the origin, right, like that. So the sine is the opposite over the hypotenuse, so it's going to be negative 1 over the square root of 65. All right, just like in the last unit, we can't leave square roots in the bottom of our fraction, so we're going to multiply it to the top. You're going to have negative root 65 over 65. For cosine, we have adjacent over hypotenuse. Again, you're not allowed to have square roots in the bottom of your fractions, so you have 8 root 65 over 65. And the tangent is opposite over adjacent. And those are the answers. Next, 14 through 16. We want to find a coterminal angle that's between 0 and 2 pi. So right now, all the problems that we have for 14 through 16 are not inside the unit circle. They're either too big or too small. So we want to make sure that they are inside the unit circle. So if they're too big, like in A, you have 13 over 6 is bigger than 2. So we want to subtract or add 2, depending on what size our given radian is. In this case, because it's over 2, we want to subtract 2. Find its fraction. So it's pi over 6, so it's 1/6. So pi over 6 is its coterminal to 13 pi over 6. All right, now what we do, for the rest of this, we find the sine, cosine, and tangent of pi over 6. So the sine is 1/2. The cosine is root 3 over 2. And the tangent is 1/2 divided by root 3 over 2. So if we have 1/2 divided by the square root of 3 over 2, we want to multiply by the reciprocal of the denominator. All this cancels, and we're left with 1 over the square root of 3. Now, like before, we can't leave square roots in the bottom of a fraction, so we multiply by the square root of 3 to the top. So we have square root of 3 divided by 3. That is the tangent of pi over 6. The next question, we got negative 19 divided by 3, which is smaller than 0. It's less than 0, so we need to add 2 to this value, which is still less than 2. So we add another 2 and another 2 until we get a positive number that's above, that is above 2, that is above 0. I just made a mistake on my own calculator. So we're going to add 2, 2, and now we get a fraction that's a number between 0 and 2, and it is 5 pi over 3. So in the first one, we want to subtract 2. We only need to do it once. The next one, we're going to add 2. a number of times until it's between 0 and 2, and we found it at 5 pi over 3. So now we find the sine, cosine, and tangent of 5 pi over 3. So sine of 5 pi over 3 is negative root 3 over 2. The cosine of 5 pi over 3 is positive 1/2. And the tangent is going to be sine divided by cosine, so negative root 3 over 2 divided by 1/2. We're going to multiply by the reciprocal of the denominator. This all cancels, and we're left with negative root 3. Is the only thing that we have left. Finally, 9 pi over 2 is too big for the unit circle, so we're going to subtract 2. And again, so we're going to get 1 over 2, which is pi over 2. So the sine of pi over 2 is going to be 1. The cosine of pi over 2 is going to be 0. And the tangent is 1 divided by 0, which is undefined. Okay. All right, the rest of the review sheet is trig identities. So I'm going to go through these and show you the progression. All right, now again, as I've mentioned before, when we did this unit, there's not just one way to do this. If you have a different way that you find is easier, then please go ahead and do it. All right, again, you can have your unit circle, please have that formula sheet in front of you so it can help you out. If you don't, well, then that's not any good. Okay, let me find my unit circle here, my formula. Did I put it online? I'll find it while I'm doing these. All right, here we go. So cosecant, you can make cosecant into 1 over sine, and secant can be 1 over cosine. Since it's a complex fraction, we're going to multiply by the reciprocal of the denominator, so we have cosine over 1 and cosine over 1. All this canceled. We're going to leave left with cosine over sine, and cosine over sine is tangent. That's what we're trying to find. Oh, sorry, highlight. Cosine over sine is cotangent. Sine over cosine is tangent. So, and that equals cotangent. There we go. Sorry about that. All right. Number 18. Secant is 1 over cosine. Cotangent is cosine over sine. All right. The cosines will cancel each other out. Be left with, let's get rid of that actually. Be left with 1 over sine. And 1 over sine is equal to cosecant, which is equal to cosecant. Okay, if you look at your formula sheet, 1 minus cosine squared is a Pythagorean identity. That equals sine squared. Times cosecant squared is 1 over sine squared. And sine squared, cosine squared will cancel. You're left with 1, which equals 1. One plus tangent squared is another trig identity, or sorry, Pythagorean identity. And 1 plus tangent squared is going to be secant squared times sine squared. All right, secant squared is also 1 over cosine squared times sine squared over 1, which gives you sine squared over cosine squared, which is equal to tangent squared, which is what we're trying to find. Okay. Number 21. To do this, what we're going to do first is distribute the bottom. 1 times 1 is 1. Actually, I'm going to write the sine and cosine on the top. 1 times 1 is 1. 1 times negative cosine is negative cosine. Cosine times 1 is positive cosine. And cosine times negative cosine is negative cosine squared. All right, negative cosine and positive cosine will cancel. So I'll be left with 1 minus cosine squared. So I'm going to rewrite that as sine over cosine, or sorry, sine times cosine, divided by 1 minus cosine squared. All right, 1 minus cosine squared is the same thing as sine squared. All right, this sign and one of those signs cancels out. I'm left with cosine over sine, which is equal to cotangent. All right. Next, for 22, I have a tangent in both terms of the left side of my equation. So I'm going to take, oops, I don't know what that was. I'm going to take tangent squared out. I'll be left with 1 minus sine squared. Okay, so tangent squared is going to be sine squared over cosine squared. And then 1 minus sine squared is cosine squared. And these two cosines cancel out, so I'm left with a sine squared, which is what I was trying to find. And 23, I'm going to turn all this into terms of sine and cosine. So I have cosecant is going to be 1 over sine. Minus cosine is already in cosine, so I'm going to leave it. And then cotangent is cosine over sine. I'm going to make this bigger because I'm going to run out of room, I'm afraid. So we have 1 over sine minus the cosines get multiplied together to give you cosine squared over sine. So we have two fractions with a common denominator, so we're going to combine them. So we have 1 minus cosine squared over common denominator of sine. 1 minus cosine squared is equal to sine squared over sine. And one of them cancels out, so all I'm left with is sine, which is what I was trying to find. Okay, and then the last question on here, we have tangent, which is sine over cosine, plus cotangent was cosine over sine. So I have two fractions. I need a common denominator to combine the two fractions. So in order to get this, I need to multiply this left side by sine over sine, and the right side by cosine over cosine. Okay, so now on the left side, I'll get sine times sine is sine squared. And my denominator is going to be sine cosine. Plus, on the right side, cosine times cosine is cosine squared. And on the denominator is going to be sine and cosine. So now I have two fractions with the same denominator. I can combine them. So I have sine squared plus cosine squared over sine cosine. All right, and then sine squared plus cosine squared is a Pythagorean identity, which gives you 1. And then I have sine over cosine. So 1 over sine is going to be secant, is going to be actually cosecant. 1 over cosine is secant. Although they're different orders, it's still multiplied, so it's still the same thing. So they're equal to each other. There you go. All right, so that is the review sheet video for Unit 2. Again, please do the corrections for Unit 2. Somehow show me that you've done some of the corrections, either for a specific power standard or for the whole test. And then contact me, and then I will arrange for you to take the retest so we